From better quantization to stable world models and self-improving language systems, today's papers all tackle a common challenge: how to make AI learn more reliably, more efficiently, and with less handholding. We'll explore a new vector quantization trick that sharpens compression and generation, a pixel-based world model that plans fast without collapse, and an autonomous training agent that keeps small language models improving in production. If you're curious where practical AI research is heading next, this episode is for you. Let's explore the first paper, the VQ differentiable vector quantization using the reparameterization trick. DiVQ introduces a reparameterized surrogate for vector quantization that preserves hard nearest neighbor assignments in the forward pass while restoring gradient flow through the quantizer. Instead of the standard STE-style identity gradient or NSVQ's isotropic noise, it constructs a directional error vector aligned with the selected code word with a small Gaussian perturbation, V, sim, mathcal n, 0, sigma, 2i, used only to define a differentiable reparameterization. This yields exact hard quantization in the sigma 2 to 0 limit and removes the need for auxiliary commitment, codebook losses, temperature annealing, or train test mismatch. The paper's second contribution, SF-DivIQ, extends this idea to space-filling quantization along line segments between adjacent code words, which increases representational freedom, reduces distortion, and empirically prevents codebook collapse and codebook latent misalignment without heuristic replacement. Across VQ VAE image compression on AFHQ, Celeba HQ, FFHQ, LSUN Bedroom, and LSUN Church, VQ GAN generation, and DAC-based speech coding on VCTK, DiVQ and SF-DiVQ consistently outperform STE, EMA, rotation trick, straight-through Gumbel softmax, and NSVQ. In the reported AFHQ compression curves, they improve SSIM and PSNR while lowering LPIPs over all tested codebook sizes, with the strongest gains at small codebooks. In VQ GAN, they avoid the catastrophic FID spikes seen under misalignment, where baselines sometimes exceed FID 300. In speech coding, they yield the best or near best LSD, MFCC distance, PESQ, and STOI across 1013 bits codebooks. The methods are drop-in replacements for standard VQ layers and are shown to generalize to residual VQ as well. Let's explore the second paper, the World Model Stable End-to-End Joint Embedding Predictive Architecture from Pixels. The World Model, LUMN, is a stable end-to-end joint embedding predictive architecture for reward-free world modeling from raw pixels. It replaces the usual collapse avoidance machinery, stop gradient, EMA, target encoders, pre-trained features, auxiliary reconstruction, or multi-term Vikreg-style losses with a two-term objective: next embedding MSE prediction and SIGREG, a Gaussianity regularizer that projects embeddings onto 1024 random directions and applies the univariate Epps-Pulley normality test. This reduces effective hyperparameter tuning to a single weight lambda versus 6 tunable coefficients in PLDM. The model is fully trainable on a single GPU with about 15 M parameters and can be tuned efficiently with logarithmic time bisection over lambda. Architecture-wise, the WM uses a Vi-tiny encoder for pixels and a transformer predictor with Eta-LN action conditioning and causal masking. Planning is done directly in latent space with cross-entropy method plus receding horizon MPC. Across offline manipulation, navigation, and locomotion benchmarks, including PushT, OG-BenchCube, 2Room, and Reacher, it matches or exceeds prior end-to-end JEPAs and stays competitive with Dynoff 2-based world models, while planning up to 48 times faster. Full planning takes under 1 second and about 50 times less time than DinoWM in the reported setup. On PushT, it improves success rate by 18% over PLDM, and it even outperforms DinoWM on that task despite DinoWM using proprioception. Beyond control, latent probing shows that LWM encodes recoverable physical state. On PushT, it improves linear probe MSE for agent location from 0.09 to 0.052 and block location from 0.122 to 0.029 relative to PLDM, while on OG-BenchCube, it best recovers end effector and cube positions. Violation of expectation tests confirm higher surprise on teleportation than on color changes, indicating sensitivity to physically implausible transitions. Let's explore the third paper, Pioneer Agent Continual Improvement of Small Language Models in Production. Pioneer Agent presents an autonomous closed-loop system for continual improvement of small language models in production, targeting 1B8B models, where data curation, failure diagnosis, regression control, and iteration policy dominate final quality. The core technical contribution is a search over training pipelines, pi equals DHS, jointly optimizing dataset composition, hyperparameters, and learning strategy, rather than treating fine-tuning as pure parameter tuning. In cold start mode, the agent starts from only a natural language task description, acquires data, constructs a held-out evaluation set before training, and iterates using agent-guided search. In production mode, it ingests judge failure traces, builds a failure taxonomy, synthesizes corrective curricula, and retrains under a hard regression constraint. RPi is less than or equal to 2 on previously correct examples. Selected runs use Monte Carlo graph search over complete training attempts, with graph lineage enabling branch fusion and stagnation recovery. The paper introduces AdaptFT Bench, a benchmark of 7 synthetic inference log scenarios plus 2 real deployment-style case studies designed to test diagnosis, curriculum synthesis, retraining, and verification under progressively increasing noise. Across 8 cold start benchmarks, Pioneer Agent improves base models by 1.6 and 83.8 points. Llama 3.23b on Arc Challenge rises from 5.3% to 72.6%. Gaius Modico to Treo für %, Trivia QA to 48.6%, and Gleiner 2 on SMS spam from F1 0.159 to 0.997. On production-style scenarios, it improves or preserves performance in all 7 AdaptFT bench cases, while naive retraining degrades by up to 43 points. On Clink 150, exact match increases from 84.9% to 99.3%. And on CoNLL 2003, Entity F1 rises from 0.345 to 0.81. A notable finding is emergent strategy discovery. The agent independently learns when to use chain-of-thought supervision, task-specific epoch schedules, prompt constraints, hard negatives, replay buffers, and rollback. That's a wrap on today's AI paper highlights. Thanks for watching.